Hello guys, so in this video we're going to continue with the question paper and look at how to answer some questions in section B of this paper. But I left out the number 18 from section A, so I'll just complete it here. I'll just do it here with you and then continue section B. So number 18 was saying if f of x is 1 over 2x to the power 4 plus x. Now find the equation of a tangent line to that function f of x at x equals to 2. You want to find it at x equals to 2, right? Okay. What you can do is you must first find the first derivative of this function f of x. F of x is given by 1 over 2 x to the power of 4 plus x. You want to find your first derivative of x, that is your gradient at any point on this function. The gradient at any point is given in terms of x because it's a function of x as well. So you have 1 over 2 times 4 and times x to the power of 4 minus 1 plus 1, because the differentiation of here is just 1. 1 times doing this thing that we are doing here, you just get 1 for that one. Okay, you can confirm it. So the first derivative is given by 2x to the power of 3 plus 1. But we are looking for the first derivative. This is the gradient at any point. Okay, but now we are looking at point 2 when x is 2. The gradient at x2, you get what? You get 2 to the power of 3 plus 1. And here you get 16 plus 1, and that is just nothing but 17. So the gradient at 2 is 17. Knowing that the gradient at 2 is 17, we can just simply go ahead and choose between the options that have 17 as gradient. That is B, C, and E. Now we have to find the y-intercept of the line, but we cannot do that straightforward. What we can do is we have to find the point. Now that we have a gradient for equation of a line, because we are looking for the equation of a tangent line, you have a gradient. Now since you have a gradient, you need a point. Let's find a point. The point 2 is to f of 2, the function value at 2, because we are looking at that point, the tangent line passing through that point on the function f. Okay, now what we can do here is we have the point as 2, and f of 2 is just 1 over 2. Put 2 to the power of 4 plus 2. That is your value. Now you get 2. 2 goes with minus 1 there. And then you have 2 to the power of 3. That is 8. 8 plus 2 is 10. Right? Now, knowing that 8 plus 2 is 10, we're going to just write the equation of a line. Now, the equation of a line is given by y equals to m into x minus x1 plus y1, where x1 and y1 are this point, this one's here, 2 and 10. So the equation of a line is just m, that is 17, into x minus x1 is 2 plus 10 here. And then you have here 17x clearly shows between B, C, and E is the answer. Now, you have 17 times minus 2 there. What do you have? You have minus 34. Minus 34 plus 10. Plus 10, you get the answer as y equals to 17x minus 34 plus 10 is minus 24. And the option is B. And that's how you do this one. Let's look at the next one. The next one here says, it's the question 1 of section B. Now we are at section B. Calculate the first derivative, the gradient at 1, when x value is 1, by using the definition of the derivative, first principles limit process. If f of x is given by this guy here, and then that will give you 5 marks. So you want the first derivative of x is equals to the limit as h goes to 0. As h goes to 0, of f of x plus h minus f of x, divide everything by h. This is where you start, and then from there you have to do the maths. Okay, this is equals to the limit sh goes to 0 of a very long thing here. Let's see what's that long thing. F of x plus h is that long thing. So we replace this x by x plus h first. Okay, so you write x plus h, and then you want to subtract 3 from that. This is that 3 minus 3. I'm still writing f of x plus h, and I want to subtract 2, that is this 2, and I want to replace this x with x plus h, because we replaced x of f of x with x plus h here. So on that function, we keep on, when we see x, we just remove it and put x plus h in its place. Okay, so we have x plus h there, and then it was squared because of this square. We want to subtract now. We subtract f of x as it is. So you just write it here as it is. You subtract x minus 3 minus 2x squared, and then you want to close there like that. You want to put everything over h. This is still the derivative, the first derivative of f, meaning the gradient at any point on f. Okay, in terms of x is given by this function that we are producing here. Now let's remove the brackets. This is the limit sh goes to 0 of what? Of x plus h. You can remove the brackets there, we don't have problem. Minus 3, then we have minus 2 into x squared plus 2xh plus h squared. Simplifying this square there, that square bracket. So we have again minus x. We just remove this negative with everything that is inside here. Okay, so we have minus x plus 3 plus 2x squared. Everything is divided by h again. And now we are looking for those that will cancel. Let's first simplify this bracket here with minus 2 with everything that is inside. Okay, so we have the limit sh goes to 0 of what? We can cancel this x with this x. X minus x is 0. We can cancel this minus 3 with plus 3 there. Okay, and then we are left with h here. Minus 2x squared minus 4xh. This is this one and this one. And then this one here, and the h squared, it will give us minus 2h squared. And then we still have this plus 2x squared there. Okay, remember this was minus 2x squared resulting from there. We divide everything by what? By h. Okay, and what do you get? Let's cancel this one with this one because they are the same things, but now with the opposite signs they can go out. So we just have the limit sh goes to 0 of what? Of, on top we are left with h minus 4xh minus 2h squared. Divide everything by h. Dividing everything by h on this equation, you have take out h as common factor. You get limit sh goes to 0 of what? Take out h as common factor, you have 1 minus 4x minus 2h there. Okay, and what do you have? You have divided everything by h. Everything, these h's will cancel, and then you are left with what now? You are left with 1 minus 4x minus 2h, and then you can just simply replace where you see h, put 0 now, let h to become 0. Okay, we don't have h in the denominator anymore, they cancelled with this one, so we just have this thing over 1. Okay, and that will be 1 minus 4. You see now I don't write the limit, I stop writing the limit when I replace h, every h that is left with 0. I'm not writing the limit here, I'm just writing the answer. The answer is 1 4x minus 2 into h, that is 0. H is 0. This becomes 0 as well. And the derivative at any point is given by 1 minus 4x. Okay, but you are looking for the gradient now at the value 1, when x value is 1. But remember, we have this one as that answer that we got there at the bottom. Okay, so this is f prime of x. So you are looking for f prime of 1. When x is 1, the gradient will be 1 minus 4 into 1, and this will be 1 minus 3, 1 minus 4, I mean, that will be minus 3. The answer is minus 3. When you sketch the function, at x equals to 1, the gradient should be a negative line. It must be something like this. The tangent must touch like this, going down with a negative slope, okay, on that function, wherever that point is. And that's how you get it. But based on the function again, you can just confirm your answer by doing the exponential, the way we do it exponential, with exponents from this function itself. Finding the derivative of this thing, first derivative of this thing is just, first derivative of x is going to be equal to, this one is going to produce 1, this one is just a constant, going to be 0, fall away, and you have this negative 2. Multiply by 2, you have negative 4 there. X to the power of 2 minus 1, that is just again 1. Okay, and that's how you find the answer. So the answer for this problem is minus 3. The derivative of the function, eh, the derivative of the function at x equals to 1, that is what they were looking for, and that derivative is this, but they wanted you to go through all this procedure and find it like that. Okay, let's look at the next question, and that is question number 2 of section B, and that is growth and decay problem. They tell you that the half-life of carbon 14 is about this number of years. Remember, this question paper, these people were allowed to use calculators. So that's why they bring these numbers, these nasty numbers that we cannot do without a calculator. But let's try to do it without calculator and see what will be the solutions. And then those who were writing this paper, that they had to use a calculator, they can just take out their calculators and punch and see the numbers clearly. But this is the procedure of how you're going to do it in MATM in case you find that it's difficult for you to do without a calculator. This is how you do it. It's a half-life of carbon 14. It's about this number of years. So it's in years. In 2010, uh, this guy, I don't know his name. It's a scientist. That scientist found a piece of cloth painted with organic dyes, the one that contain carbon. Okay, that one, yeah, they say, they mention it here, they contain carbon 14. When analyzed, they saw that only 77% of the initial carbon was remaining. When was this thing painted? They want t, solve t such that when we say 2010 minus that t will be that when, well, maybe 2001, we will find that answer. Maybe then t will be what? Will be the difference between 2001 and 2010. Okay? So we start by doing what? We start by saying the amount of this carbon at time t will be carbon, initial carbon that we had, times e to the power of kt, because it happens exponentially like that. Okay? It's half-life. At half-life, if they say C naught. This is C naught. Initially, you will have C naught. It will become half of C naught after 5730 years. Okay, this is your time. This is your time t to get a half life of this carbon. Okay, this is your time t. So let's just go into into our formula and substitute that data here and find the solution to the problem. We must first find the growth constant that we don't know. K. We must solve for K. Okay. Now what we do is we have C at time t. At time t, after this many years, we get carbon at time t, and that carbon at time t is now half of carbon initially. Okay, carbon at time t here, after this is after this time, after this years, we get this carbon. It is now half of that carbon. Okay, equals to carbon initial is still carbon initial, e to the power of k, t is 5730. Okay, and then the c naught will cancel, divide by c naught, both sides, the c naught will cancel. Now you have here 1 over 2 s e to the power of k. Let me write it like this: 5730k. Okay, so you must take the ln of both sides to have ln of 1 over 2 equals to, this side, when you take ln, you have 5730k ln e. Ln e, I must write it here, ln e, but now ln e is just 1. Okay, doesn't matter if I don't write it. Solving for k here, I get that my k is equals to ln of half, or you can just say 1 over 5730 ln of 1 over 2. This is my growth constant. Okay, and this my growth constant might be negative. Yeah, it will be negative. Look at it, we have 1 over 2 here. That is just 2 to the power of minus 1. 2 to the power of minus 1 in front of ln, this minus 1 can come in front of the ln. So this minus 1 will be ln 2. Ln of positive 2, the function of ln positive 2 is a positive value. Ln 1 is here, is 0. 2 is there. Ln of 2 is something that is positive. Okay, and when it's positive, ln 2, but now the negative one that we put in front of here will come. Okay, when we have ln 2 there, and that is a growth constant that is negative. Why is it negative? Because this thing is decaying, is decreasing. That is why the growth constant is negative. You keep on subtracting something from the initial amount. Okay, now that we have the k as this value, we just have to go back to our formula. That if you can check it, let's go and check it. It was this formula here. Okay, we have to come back here and substitute our k as that value that we found down there. Okay, and say c of t will be c naught, that we don't know, e to the power of k is now that value. I'll just keep it as k for simplicity of this question. I'll just keep it as k and write it at the final answer. Okay, just keep it as kt, but don't forget that k is this value here. You have to find the value of k. But if it is simple for you because you're not using a calculator, maybe you'll find something like 3, or it depends, -2. It depends on out of one guy. So we can now answer the question that was saying, when analyzing, they saw the only 77% of the original value was remaining. When was it painted? When was it painted? We can answer that question and say, okay, at time t, only 77%, 77 over 100 of c naught is there. This is our c at time t that you are looking for. The t that you are looking for. This is our c. Our c is 77% of the c naught. Okay. Our c of time t that we are looking for, the t that we are looking for, it will be given by what? It will be given by 77%. 77 over 100 times the c naught, the initial value. This is our c at time t. It's problem solving skills that you must have when you are dealing with calculus, guys. Okay, now c of time t, c at time t is 77 over 100 of c naught. You replace c of time t with that value, because after time t, that's what will be remaining, 77% of the c naught. When we started with what? When we started with c naught, e to the power of k, remember we have it, t. Okay, and now we can solve the value of t. First, let's divide by c naught everything, so that we get 77 over 100. as what? You get it as e to the power kt. And that time in years that you're going to get, t is going to be what? T is going to be um, um, uh, ln of this. Just take ln of both sides and then you divide by k. Let's, for simplicity, let me not rush it. You have kt equals to ln of 77 over 100. Okay, and then you have your t as 1 over k ln of 77 over 100. This is your t. And therefore your final answer in the year that you are looking for, it was in year what? You can say therefore it was in a year n when they painted it, or they applied the carbon, whatever the story is up there, where n equals to 2010 when they analyzed it, minus 1 over k ln of 77 over 100, because this is our time t in years. So we want to subtract from 2010 that answer that we are getting there. Because I'm not using a calculator, this is how I'll write it, and this is what you must do if you encounter a challenge where you don't know, you don't have to use a calculator in exam. So our 1 over k here, what is our value of k? Our value of k was, if I remember very well, 1 over 5 7 3 0 ln of 1 over 2. You will put it here, and this will be the final answer. It was in this year. This is a year. This whole thing here represents a certain year that we don't know. Let's look at the next question. Number 3 here is straightforward. Determine h of x if use the sketches. These ones are the sketches of f of x there, and you have your g of x there. Okay, those are the functions. Now they will say h of x is given by this thing here. Determine what is the value of h of x. Okay, so the value of h of x equals to the limit of f of x as we approach -1. I mean, as we approach -1 from the right side of -1. Here is our -1. We want to go from that side. As we go that side, what is the limit of the function? We find that the limit of the function is there, is 3. Okay, the value here is 3 as we go from that side. So we write 3 there for replacing this thing. We replace it with 3. It's in the bracket. Okay, you want to subtract the derivative of g at 0. Here is at 0 on z, so g is that function, this one here, and then the derivative at 0 is nothing but 0 because it's a turning point of g. You see, it's a turning point of g. The gradient there is 0, so we replace the gradient of g at 0 is 0 again. You must know the turning point. The gradient at the turning point is just 0. The gradient that looks like this is positive. The gradient that looks like this is negative. But this one is a horizontal line. A tangent passing through that turning point will give you a gradient of 0. Okay, so that will replace like that. And we write this bracket here. That is bracket of the derivative of the function f of x at 2, the gradient of the function f of x at 2. This is just a straight line going down like that with a nice triangle there that I can just use to calculate the dy over dx. That will be the gradient of that line. That is just 3 over 2, but because it's going down, it's -3. You can calculate it by the points 3 0 0 3 and 2 0, these 2 points. Okay, you will get 3 minus 0, that is 3 minus 0 over, you get 0 minus 2, 0 minus 2, and this will give you -3 over 2. But with that triangle, that you just get it simple like that. So the value for f prime at 2, because why we saying is the same as that value, the gradient of the line, because the gradient of the function f at 2 is the gradient of this straight line that keeps on going down like that. And so is the gradient of that line then. The gradient of the function at 2 is the gradient of the very same function at 2. And then that is just minus, we said it's minus 3 over 2. Okay, minus 3 over 2. And then we want to add with what? The function value at minus 2, the function value that is g. Okay, this one here, let me zoom it for you so that you can see at what's happening at 2. At 2, you have the function value there as 0. You can clearly see it here. It's 1, 2, 3. So at 2, you have the function value as 0. The function value is 0 there. Okay. So you want to add that with 0. That is the function value at minus 2. Oh, well, I was looking here. I was supposed to look at minus 2. Minus 2 is there. But it's the same thing. It's 0 again, okay? You can clearly see it's the same value function there. It's symmetrical, this function. And therefore, that value will also be 0, okay? Sorry about that. But it's the same procedure. And then we have 3 here. You want to multiply it by negative 3 over 2. Because this is 3 minus nothing is 3. Minus 3 over 2 plus nothing is again minus 3 over 2. Multiply those ones, you get the answer is minus 9 over 2. And this is the final answer for that 4 marks. Okay? And that's how you interpret the questions in calculus. Thank you for watching this video, guys. Please don't forget to like, share, and comment on this video. You can comment and say, I need you to help me with this topic of mathematics, and then I will see if I can do it. Okay? Thank you very much. Bye.